So hello students, so welcome to my next online class, and in today's video I am going to discuss a new chapter, that is pressure in fluid. Okay, so you see I have noted down few points here, so one by one we will go through the points, and in this video at the end I will be asking few questions also. So that questions also you need to write in your textbook. So do view the video completely. Okay, do not skip the video. So let's start our today's class. So first topic we have thrust and pressure. So what is thrust and what is pressure here? You see, suppose you have one vessel and the vessel is containing water, and gently you have placed an object on the surface of the liquid. So the weight of that object is the force which is acting perpendicularly in that liquid. Okay, that means that object is exerting force on that liquid, so that is nothing but a thrust. That means force acting normally on a surface is called thrust. Okay, now that thrust depends upon the surface on which it is exerting the force. That means object force is exerting on what surface? That object where you have placed, whether it be liquid or whether it be solid. So it depends upon the area. So therefore pressure is defined as thrust acting per unit area. So thrust by area is pressure, whereas thrust is the force acting normally on the surface. Now when I say pressure, pressure equals to force per unit area, and this force means thrust. So thrust and force is same, but the force acting normally on a surface is called thrust. Force acting normally on a surface is called thrust, whereas thrust per unit area is called pressure. In our junior classes we have learned how pressure and area of cross section are related to each other. They are inversely proportional to each other. We have seen various examples in class 8. We have gone through this chapter, we had this chapter, and we have seen that if area of cross section is very small, that means pressure exerted will be more. Like for example is knife. If the knife is very blunt, then it will not cut the vegetable easily, but whereas it is very sharp, then it will cut easily. Moreover, your straps of your this school bag, now if it is very thick, then it will exert a less force, so it will less hurt your shoulder, whereas if the strips are very thin, then it will exert more pressure. Okay, so therefore pressure and area are inversely proportional to each other. That was pressure and area. So here pressure equals to thrust per unit area. Thrust means here force. Now what is the unit of pressure here? You see, force when I say that is Newton, and area when I say that is meter square. That means Newton or Newton per meter square, we can say this one. So this is the SI unit, or we can say Pascal, that is PA. It is denoted by capital P, small a, Pascal. Okay. Now what is the CGS unit of pressure then? That is force means here it will be dyne, and area means here centimeter square. So we say or dyne per centimeter square. So this is the CGS unit of pressure, and this is the SI unit of pressure. Okay, so in SI unit we can say that is Pascal or Newton per meter square, and in CGS unit we will be saying that it is dyne per centimeter square. So this was all about thrust, pressure, and units of pressure. Next we have pressure in fluid. So what is fluid actually? Fluids are the substances which has an ability to flow. So not only solid is exerting pressure on a surface, definitely this liquid and gases, they also exert pressure. Like in a vessel, when it is contained with either gas or liquid, that liquid is exerting pressure on all the walls of the container, not only in the bottom but also at the sides. That pressure we call it as lateral pressure. That means the pressure exerted by the fluid on the outer walls of the container is called here lateral pressure. So due to lateral pressure only, if you pierce a hole in that container, the substance will be coming out. Okay, so with a single pressure. So now if you pierce a hole in each and every side of that container, the pressure will remain same if it is at same height. But if the hole which you have made are at different position, that means pressure will also vary. That means pressure also depends upon depth. That one will come more detailedly in further topics. You see, pressure within a liquid. When you are immersing your hand in a bucket containing water to a different depth, you will find or you will experience a pressure at different depth of the liquid. That means if you go increasing the depth, means if you increase the depth of the liquid, that means pressure will increase. That means pressure increases with depth. Okay, you see, let me give one example. Like for example, you see the dam foundation is made very thick at the bottom, whereas it is made very thin at the edges. Okay, so you know dams are the constructions where we store water for producing electricity, and generally we do it in hydropower electricity, that is stations and all. So large construction has been done where water is being stored. So while constructing a dam, we have to keep it in mind that the base or the foundation should be made very strong. If it is not made very strong, then it cannot withstand high pressure. So when the water is contained in a dam, and if the base or foundation is not made strong, then easily it can break. So therefore, as the dam is having very high, that means the depth is very high, so the foundation is made very strong. So from here we come to know that means if the depth of the liquid is more, that liquid pressure will be also more, and it is less at the surface. Okay, so if when you are swimming also in the sea or in an ocean, if you find that the liquid pressure, as you go more depth, liquid pressure will be more than at the surface. So next we have manometer. Now what is this manometer? You see, I have drawn a diagram here. Manometer. So manometer is a device which is used to find a pressure of a gas contained in a vessel. Suppose there is one vessel and it is containing some gas. Now you need to measure how much pressure is there in that vessel of that gas. That means that pressure of the gas can be measured by using a device that name as manometer. Okay, so I'll just explain you how we can measure the pressure of that gas. Okay, you see this manometer has two arms. Okay, and this manometer, one end is connected with the gas whose pressure you have to measure, and one end is just open where air pressure is acting. Now that manometer is contained with a liquid called mercury. Okay, so mercury has a high density, so generally in a barometer or any other instruments, generally we prefer mercury only. Okay, due to its many reasons, due to its density, due to its shininess, okay, due to its availability, so generally we use mercury only. So in this manometer, one end is connected with the gas vessel and one end is open, and this manometer is contained with this mercury. Now when you see, when this one end of the gas is not connected to the vessel, for example in the initial case I am talking about, that end due to air pressure we will find that mercury level is same in both the arms. Okay, when it is not connected with the gas vessel, I repeat, so the level of the mercury in both the arms will be same, but as soon as this is connected with the gas vessel, the pressure will be exerting here, and due to this pressure the liquid in one arm will get decreased and the mercury in other arm will increase. Let us consider it as increase up to here. Okay, so as this gas is exerting pressure on the surface, that means the liquid in other arm is also increasing with that much height. So from here we can say the more the pressure, more will be the height. Okay, also it depends upon the density of the mercury. That means this height will not be same if you pour this manometer with any other liquid like alcohol or water. So that means this pressure depends upon height, this pressure depends upon density, and also it depends upon acceleration due to gravity. Also it depends upon the air pressure, that is atmospheric pressure, which we know air pressure means here atmospheric pressure. Okay, so what is the total pressure of the gas then? Total pressure of the gas means atmospheric pressure, that is PA, and h rho g, that means height. So at what height the liquid has rest on the other arm, what is the density of that mercury, and the acceleration due to gravity, right? So this is the total pressure of a gas. So in your screen you can see one diagram, that is a pressure in liquid. You see there is a vessel is containing some liquid here, and in that liquid I have considered one layer, that is AB. This AB layer is still, okay, when you are not moving the vessel, that means AB layer is still. This indicates that the pressure exerted by upper layer on that layer is equal to the pressure exerted by lower levels. That means how much pressure is exerted from down to up, same pressure is exerted from up to down. So both the pressures are balanced, so therefore AB layer is also balanced. Okay, so at a certain point in a liquid the pressure is always balanced. So this was the manometer which I was talking about. So one end it is being connected with the gas whose whose pressure you have to calculate, and when it was not connected the liquid was at B and T, that means liquid level was same. But when it was connected with the gas, due to pressure, that means the liquid level has rised up. So the total pressure of the gas equals to pressure of air, that means atmospheric pressure, plus height, density and acceleration due to gravity. So depth and pressure. So I was talking about depth. You see, let us consider a vessel containing liquid, and we have made 3 holes on the 3 layer. So when you open all the nozzles of the 3 openings, you will find the water emerging from the hole which is near to the bottom covers more distance than that of the other holes, right? So this indicates that pressure increases with depth. So more the depth, that means water liquid. Now why the reason is here why it is more, why the pressure at the hole near to the bottom is more than that of the other. Because you see, when the hole is here, the water liquid above it has more weight. So as it has more weight, so it will exert more pressure. So due to more pressure, it will cover more distance. Okay, but whereas you see this point, the water above that hole is very less, that means pressure will be less, that means force will be less, so due to which it will cover less distance. So this was pressure equals to H rho g. So this is a derivation of H rho g, that means pressure depends upon height, density and acceleration due to gravity. So it is said here you have been taken a horizontal cylindrical body of area A and height h. So you can see here this body is taken and it is being dipped in a container containing water. Okay, so when it is dipped in here, as you have seen in the diagram, so there was one vessel and the vessel is containing some liquid, and in that liquid one cylindrical body is immersed. Now we need to calculate this cylindrical body will exert how much pressure in this liquid. Okay, so let us consider A be the area of this, the body which is being dipped here. This cylindrical body area is A. Let us consider its height is h. Okay, and the density of this liquid is rho. Okay, so we know volume equals to mass by, or density equals to mass by volume. Now if we cross multiply mass, that is mass equals to volume into density. I repeat, density, when I say density equals to mass by volume, but when I calculate mass, that means density into volume. Now volume means here, what is the unit of volume? We know it is meter cube, right? So what we have done here, how we have calculated volume here? First we have calculated its area. Area, what is the unit of area? Meter square. What is the unit of height? That is meter. That is meter into meter square, meter cube. So in place of volume we can write AH. A means area and H means height. That means AH means here volume, right? And density of the liquid was rho. So what we have got in place of M? M equals to AH rho. Now we know whenever we are placing any object on the surface, the force exerted by that object is equal to its weight. So again, that weight is equals to its thrust. How much force it is exerting normally on that surface. So therefore I have written here weight equals to thrust. That means thrust means here weight of that object. So weight means again m into g. M was ah rho and g means acceleration due to gravity. So total weight we got ah rho g, right? And weight means what? Thrust. So pressure equals to thrust by area. So in place of thrust I have substituted by the expression of weight, because thrust and weight both are same. So in place of thrust we wrote ah rho g. Now a and a got cancelled. What we got? H rho g. That means pressure is directly proportional to height, directly proportional to density, and directly proportional to acceleration due to gravity. But if I say what will be the total pressure, that time the total pressure, that means Pt will be P0 plus H rho g. Okay, what is P0? P0 is the atmospheric pressure. Okay, so atmospheric pressure plus H rho g, the pressure exerted by this object. So this thing we have to note down. So whether in the question it is asked total pressure or the pressure due to cylindrical body. So in your screen I will be showing the diagrams and I will explain here, so that when you refer your book you won't find difficult. So experimental verification of laws of liquid pressure. Now what are the laws of liquid pressure? That one we are going to explain. So there are number of laws are there, so one by one we will come to it. So here first of all what it has been done here, so one container is there, container is containing liquid here, and one side it is connected with the threshold funnel. Okay, this is the threshold funnel. Okay, and it is connected with a manometer. Okay, so we can understand what is the pressure of this fluid. So already I told manometer is a device which is used to measure the pressure of a fluid. That means it can be gas also, it can be liquid also. So one end of this manometer is connected with the threshold funnel. So first law says that pressure is same in all the direction about a point in a liquid. That means when you fix the threshold funnel at a fixed point, and when you rotate the threshold funnel in left right, like in different position, if you move this threshold funnel, then you will find the pressure will not change, the pressure will be same. Okay, that means pressure is same in all direction about a point in a liquid. Or you can say, like in this vessel, if you make hole in same level, that means pressure coming out from the three holes will be same. Okay, so this was the pressure is same in all direction about a point in a liquid. So this one already we know, liquid pressure depends upon density. More the density, more will be the force exertion, then the pressure will change. Okay, so how much pressure is exerted by mercury, less pressure will be exerted by this water or alcohol. So liquid pressure depends upon density, because the weight of denser object is more than the weight of the lighter object. So therefore liquid pressure is directly proportional to density of the liquid. Next we have liquid pressure depends on depth. So already I told that more the depth, more will be the liquid pressure. That means liquid pressure increases with depth from the free surface of the liquid. Next we have pressure is same at all points in the horizontal plane in the liquid. That means same here, the pressure remains same at same horizontal plane. At the same point also it remains same, as well as same horizontal plane. A liquid finds its own level. That means whatever may be the shape of the tube, like you see in this diagram, there is a connecting tubes, and all the connecting tubes are of different shape, and they are connected with a base which is containing liquid. Now the liquid level is same in each and every tube. This indicates that it does not depend upon the shape of the tube. Okay, so liquid seeks its own level. Whatever may be the shape of the tube which is immersed with the base, the liquid level will be same. Consequences of pressure, that means what is the result of pressure on liquid. So generally we place our water tanks on the top of our terrace. Okay, So because at higher level the water pressure will be more. Some problems we'll see is in few homes. You see, first of all, the storage tanks are kept at height. So if it is kept at height, the pressure of the liquid running to our home will be nice. Similarly, suppose the water which is going from the ground floor to the upper floor, if the height will be very more, that means the pressure level will be very less when the water will move from ground to up. But generally what we do, we place the water supply at maximum height. Okay, so more the height, more will be the liquid pressure. And conversely, if the water is at ground level and you need to take to a top floor, then you have to use pump in that case to compensate that height. So this one already I have explained. Walls of a dam are thicker at the bottom. So you see at the bottom it is thicker because the liquid pressure is more at the end. Not only the dam, these divers, means the swimmers, those who are swimming, and sea divers, generally we call them as sea divers, they use a special swimming suit, okay, to withstand the high pressure. Because if they don't wear such type of dress, when they will go underneath the water, so as there will be high pressure, so they may face difficulty, okay, in a suffocation, or there may be a bleeding from their blood vessels. So to withstand this high pressure, they use a special type of suit, that is called diver's suit. Now what type of question might come from here? You see, so why the swimmers they use special suits? That means that answer you need to find from here. Okay, why the walls of a dam are made broad at the foundation, at the base? So this type of question, in deep region question, you have to prepare. Why the water supply is kept at high level, or why the water pump is used to pump a water from lower to high. Similarly, explain how water seeks its own level. So what are the laws of liquid pressure? So one by one laws you have to explain. Okay, just you need to write this topic, or with the help of diagram you can explain. Okay, so no need to write very detailedly here, but the main theme, like it is depending upon depth, it depends upon density, it depends upon this liquid pressure here at the same point it remains same, at same horizontal plane it remains same. So like this, the topic wise you have to note down. So next we have this most important of this chapter, that is Pascal's law. So according to Pascal's law, pressure exerted in one end is transmitted equally in all directions. So this law can be easily understood by this diagram. Let us consider there is a bulb, and bulb is containing some liquid and it is connected with some piston, like syringe and all, like injection we see. So like that one piston is connected. Now as it is connecting with liquid, so each and every point I have made one hole, and when I just push this plunger, it has been seen that the pressure of liquid from each and every hole remains same. So this indicates that when a pressure is applied in an enclosed vessel, it transmitted equally in all directions. That means pressure in a liquid remains same. So if there is one vessel and that vessel is closed in one end, and from one end you are applying pressure, that pressure which you are applying will be transmitted equally in all directions. So this was Pascal's law. So what is the advantage of this law? This law is used in hydraulic machine, like in garages and all. It is used to lift the cars, heavy objects, heavy vehicles. Okay, so by applying a small force in one end, it exerts a large force on the other end. Okay, so pressure exerting in area A, that means a small area of cross section, the pressure is said to be as P equals to F1 by A1. We know pressure equals to F by A. What is the pressure exerted in piston A? That is F1 by A1. What will be the pressure exerted at piston B? That is F2 by A2. Okay, so in here that will be F2 by A2. It is misprinted here. So we know the pressure remains same, means whatever pressure will apply here, same pressure will be transmitted here, because they are connected to each other here. So F1 by A1 equals to F2 by A2. But when you cross multiply, F2 becomes F1 by A1 into A2. So you see, the force which is produced is the multiplication, is in multiplication. That means F1 by A1, whatever the value we had, that pressure into area of cross section. That means mode will be the area. That means in other end, mode will be the area of cross section more thicker, then more pressure will be exerted. So Pascal's law states that when a pressure is exerted in an enclosed vessel, it gets transmitted equally in all directions. Therefore, force produced in smaller cross section produces a larger force in the other end. Okay, so this F1 by, F2 by F1 equals to A2 by A1, or you can say F1 by A1 equals to F2 by A2. So same concept is being used here also, that is hydraulic press. So a small pressure is being applied here, and the bale of cotton, suppose in from the cotton the seeds you have to extract. So this is used in a factory there. So a small force is applied in one end and it produces a large force, and due to which the cotton gets squeezed and the seeds or the oils easily comes out. Okay, so this is a hydraulic press. So how hydraulic press works, so you need to draw the diagram and briefly you have to write about hydraulic press. How hydraulic machine works, so you need to draw the diagram is must, and you need to write briefly. Similarly, you will be going through this hydraulic jack, okay, and hydraulic brake. So you will draw the diagram and you will make a small note on this. Okay, so I am leaving this one as a homework. So today's question, as I have already told, I will be asking question at the end. Today's question is that why the tires of a heavy vehicles are very thick. Okay, next question, why a sharp knife is used for cutting the vegetables, not the blunt knife. Why camel easily walks on the sand, or we call it as sheep of a desert. What is the difference between thrust and pressure? And how a hydraulic brake works. So these questions also you have to include there. Okay, and the exercise questions. So a few questions which I have already asked here, you might see that they are already there in the exercise. So these questions you have to do. Okay, so this will remain as a homework. So in the next class I will be solving few numericals here for you. So this portion you need to complete. Okay, if necessary you can make note in your exercise book also. You remember I used to do in class 8 also, I used to make you write the topic wise and the note wise as well as the question answers. So same thing you will be doing here. For till now, thank you.